Label all three sides of any triangle. Now look at that triangle. Those values represent a unit of length. Now look at that triangle. Those values represent circumferences of the ball. Now look at that triangle. Those values represent degrees. But how can that be, you say? Because we've been sleeping on God. Now look at this 30, 60, 90 triangle. Not only do these values represent units of length and circumferences of the ball, these values represent a radius and a diameter, a half circumference and a circumference, 180 degrees and 360 degrees. And this is the value that connects it all. Also, it's squared. 1.8 squared plus true pi squared equals 3.6 squared. You see, in the true 3.6 inch circumference circle, pi, true pi, is the circumference of the ball at 60 degrees. And inside this circle, the diameter is equal to the square root of 4/3. And whenever pi is the circumference at 60 degrees and the diameter being 1, it is also the equilateral triangle inside of that ball. And the equilateral triangle height is equal to the square root of 3/4. The equilateral triangle height reciprocates the diameter of the circle. So when you multiply them together, it equals 1, which is also the equilateral triangle length's square. All the squares of the triangle and circle originate from this 3.6 inch circumference circle. Let's solve a quick example problem. We'll take a 45-degree triangle. Let's get the height inside the 45-degree triangle. This measurement, we're going to use it square. This measurement squared is equal to 0.6 repeating. A 12-inch diameter, 12-inch hypotenuse is going to be our example. To get our equilateral triangle height, we're going to take 3/4, 75% of our diameter, which is 9. We're going to multiply those together to get our balance number, our reflection number. 12 times 9 is 108. So we're going to take our 0.6 repeating. Since we're using squares, our problem's going to have a square root, 0.6 repeating times 108, and you'll see that you get the correct answer. Lift up your heads, O ye gates, and lift them up, O ancient doors, that the King of glory may come in.